Okay, hello everyone. I'm Romar Vegas Commercial from IF46 INT. So in this occasion, I want to explain the text about the video on week 4, which is about the convergence test in the series. So here I already choose four even number from the problem solving of week 4. I choose it in each method of proof, which is first here it has a integral proof for test is it uh, is it a convergence or a divergence series. So we have a series that starts from 1 until infinity, 2 over 3n plus 1. So first we try to make it on the integral form, then we just replace infinity to whatever alphabet that we want. So I choose a, therefore I start with limit from a to the infinity, start from 1 until a, 2 over 3x plus 5 dx, dn as well I choose to x and dx to x. Okay, so here after this we have uh, try to change the x to the t. So the t here we have is 3t. Okay, okay, 2 over 3t dt. After this 2 over 3t we can move it to the left one, so therefore we have 2 over 3 times 1 over t dt, integral 1 over t dt. So we know that everything that by everything that over something it's ln, right? So the integral of 1 over t dt is equal to ln t, ln absolute value of t. And we just try to put again the limit here from 1 to a. Therefore we have 2 over 3 times ln absolute value of 3x plus 5. We try to return back the value of t, which is 3x plus 5. Okay, the 3 value is 3x plus 5. So here we have a calculation. A I put here, and 1 I put here, the second equation, a in the first equation. So everything that the a, we already know that it is infinity, right? So we just only have minus 2 ln 2 here. So everything that every infinite that minus something or plus something, it is infinity, it's equal infinity. So because the test said that it's equal infinity, this series in the integral test, when the value is equal to infinity minus or plus infinity or close to minus or plus infinity, it is a divergence series. So the series is divergence. It's divergent. Okay. So we move to the second question that I will make. So the second question is about the p-test. Okay, we try to use the p-test. Okay, and I already choose one of the odd or even number from the using p-test question. So here we have that uh, n start from 1 to infinity uh, of 3 over n to the 5 over 3. So according to the p-test theory, which is since the power of n is greater than 1, that means the series is convergent, or the power of n is less than 1, it's equal to divergence. Just simple as that. Because of here the power of n is 5 over 3, which divided 5 over 3, that's equal to 1 over 6. So that's mean 1 over 6 is greater than 1, right? Yeah, 1 over 6 is greater than 1. Then the p-test so that the series is convergent. Okay, This series is convergent. Done. Next to the third equation, here we have a direct comparison test. So I already pick also one number here is the sigma and start from 1 to the infinity 1 of 1 over 3n square plus 2. Okay, here we try to compare of the an equal the an to the bn, an sigma to the bn sigma. Therefore I choose the bn is 1 over n, 1 over n. Now we try to compare. Okay, now we try to compare. Okay, here we have the an equation, right? We just try to input a value start from 1, 2, and also 3. So when the value is 1, it's equal to 0.2. When the value is 2, it's equal to 0.07. When the value is 3, it's equal to 0.03. It's for the an equation. When we come to bn, it's pretty different. When the value is 1, it's equal to 1, because 1 over 1 is 1. When the value is 2, it's equal to 0.5. When the value is 3, it's equal to 0.3. So now we try to compare. In the direct comparison test theory, it says that when an is less than bn, then the series is convergent. Or the an is greater than bn, that means the series is divergent. Because in our case, we have that the an that it's always less than the bn. You see, 0.2, it's less than 1, right? 0.07, it's less than 0.5, right? 0.03, it's less than 0.3, right? So here we have our series is convergent. That's it. Okay. Next to the last question here, we have ratio test that combine with the limit comparison test. Okay, I already picked one equation. Here we have the equation. Sigma n start from 1 to the infinity of 2 to the n plus 1 over 5 to the n plus 1. We try to make it to limit. That's why we're gonna have limit n to the infinity 2 to the n plus 1 over 5 to the n plus 1 over 2n over 5n. This is the ratio test. In the ratio test, it means that every n is plus 1 for the first numerator and denominator. Everything is first is plus 1. Okay. But to the second numerator is just left this. Okay, just left like this. The second numerator and denominator, so just left like this. So that's why we're gonna have like this. It's according to the ratio test rules. Therefore, we just try to times it. The far one times the far one, the close one times to the close one. So we have limit n to the infinity 2 to the n plus 1 times 5 to the n over 5 to the n plus 1 times 2 to the n. So we just try to times it again. Just times it 5 to the n times 2 and times 1. So we have 2 to the n plus 5 to the n over 2 times 5, 10 to the n plus 2 times 1, 2 plus 2 to the n. In order to simplify this, we try to divide it with 10n over 10n. Okay. We try to multiplicate it with 10n. We try to multiply each number with 10n over 10n. It's because of this, okay? We have this 10n. So therefore we have 10 over n, 10 to the n over 10 to the n times 10 to the n plus 10 to the n over 10 to the n times 5 to the n, okay? It's clear, right? It's clear because 10 to the n multiplied with this and 5 to the n, multiply it with this, so it's plus, sign plus this, okay. And the same with the denominator, 10 to the n, 10 to the n times 10 to the n here, plus 10 to the n over 10 to the n times 2 to the n here, okay. So we try to simplify it again. Here we're gonna see here, 10 to the n is still 10 to the n. 10 to the n over 10 to the n is 1, right? Yeah, it's 1. So here, 10 to the n times 1, yeah. Plus, this 10 to the n just times to here, and this 10 to the n remains like this. So 10 to the n times 5 to the n over 10 to the n. Clear? So the same with the denominator, the same. After this, we are gonna have like this, right? 10 to the n times 1, 10 to the n times 1, it's equal to 10 to the n. So 10 to the n times, here we're going to have 5 over 5 to the n over 10 to the n. We can simplify it like 1 to 1 over 2 to the n, right? Because divided by 5 and 5 is equal to 1 over 2 to the n. The same with this, divided with 2, 2. So we have 1, 2 with 2, and we have 1 to the 5n. Okay, right? Yeah. So 10 to the n, 10 to the n, here we can remove it, right? I remove it, so it just remains 1 plus 1 over 2 to the n over 1 plus 1 over 5 to the n. So here we just directly calculate everything that over infinity is equal to 0. So here is 0, 0, so 1 plus 0 over 1 plus 0 is equal to 1. Okay? In the limit comparison test, when the limit is uh, equal to some value, equal to has same value, has some constant value, when the limit has some constant value, so the series is convergent. But when the limit has like yeah, close to the infinity plus or minus infinity, so that means it's is divergent series. So because here we have the constant value 1, so then the series is convergent. That's it. Okay, so this is my explanation. Thank you very much.